We're going to go ahead and take a look at lines today. We've talked briefly about lines, but we're just kind of reviewing this. Remember, your slope is the change in y's over change in x's. Now, if you're dealing with a horizontal line, like this one here in blue, it would always be in the form of y equaling some number. And since it's horizontal, it has no rise, doesn't go up and down. So therefore, it would be 0 over a number, so your slope is 0. Here you'd have a vertical line in green. Vertical lines are always in the form of x equaling some number. Your slope is undefined. Since you're not going left and right at all, the two x coordinates on your line would be the same. When you subtract two things that are the same, you get 0 on the bottom. And if the bottom of a fraction is 0, you can never divide by 0, so that's why your slope is undefined. Here, if we look at the purple one, you're going down as you go to the right. That's a negative slope. And it's also going to be in the form of y equals mx plus b. Any diagonal line will always be in this form. So the red line going up here would have a positive slope because you're going up as you go to the right. And it would be in the form of y equals mx plus b. Now, the y equals mx plus b is your slope-intercept form where m is your slope again and b is your y-intercept. We'll also be using your point slope formula quite a bit. Once again, m is still your slope. Your point is your x1, y1, and you could just plug that in once you were given that. Also, as a review, slopes of parallel lines are always equal or the same. Slopes of perpendicular lines are opposite reciprocals or referred to as negative reciprocals. So let's go ahead and find our slope here between these 2 points. So you're going to have to go ahead and look at your y values. Your y values are these, and you're going to have to go ahead and subtract those. So we subtract these, and we get our -3 minus our -1. Now we're going to have to go ahead and subtract our x values in the same order. So we're going to have to take this x value minus this x value. And so on top, we get a -2. On the bottom, we get a -10. That reduces down to be a positive 1/5 for your slope. Here we need to go ahead and find the equation of a line perpendicular to this line, but going through this point. Well, if it's perpendicular, we know our slope is the opposite reciprocal. So you first of all got to figure out the slope of this line. To do that, you want to get y by itself. So it's in the form of y equals mx plus b. So subtract your 3x. Get rid of your 2 by dividing everything by 2. So we get the slope of this line here to be our -3/2. Well, that's our slope. But we're looking for the perpendicular slope, which is the opposite reciprocal. So you got to flip that upside down, change the sign in front, and so you get your slope to be a 2/3. Well, our point is this. Since we are given our point and we are given our slope, I'm going to use the point slope formula. So I'm going to go ahead and replace my m with my slope. Plug in my x coordinate of 4 for my x sub 1. Plug in my y coordinate of 5 for my y sub 1. Now I'm going to just go ahead and get rid of the parentheses by distributing through, get y by itself, so I'm going to add 5 to both sides. And there's your equation down in green for your line. So now we need to find our slope and our y-intercept. Well, to do that, it's going to be easiest to have it in the form of y equals mx plus b. So that means we need to solve it for y. To get y by itself, we need to go ahead and get rid of our 7x. So let's subtract 7x to get it on the other side. Then you got to get rid of your 4. And so you get this here, which then simplifies down a little bit. You could write this first part then as a -7/4, all multiplied by x. When it's in the form of y equals mx plus b, what's in front of your x is always your slope. What's subtracted or added after your x is always your y-intercept.